The Rocard report in 2007 points out how the growing disinterest of young people towards science is a capital danger for the future of Europe and indicates that the origin of this issue can be found, among other causes, to the way science is taught. It recommends teaching methods not tied to memory learning or abstract concepts and promotes research-centered approaches on how the process of science takes place, even historically. There are many studies that value the use of the history and nature of science for its numerous educational effects. Among them, it facilitates the comprehension of science. It increases students and participation, and favors interdisciplinary learning approach. The main objective of the teaching proposal is to convey to the students how the birth and genesis of the concept of today's science was a long and tortuous path, using an engaging and different approach so as to overcome the traditional separation between humanistic and scientific disciplines. The theme treated as a supporting background is the astronomical discoveries of Galileo, for their numerous consequences in astronomy, physics, philosophy and religion. What we propose here is a multidisciplinary and interactive course, inspired and built starting from one of the recommendations of the EU Council of May 22, 2018. Relating to key competencies for lifelong learning, suggesting to promote the acquisition of skills in science, technology, engineering and mathematics, taking into account the links with the arts, creativity and innovation. This work involves the use of multiple teaching strategies such as reading and discussing the original texts to develop the critical thinking, the flipped classroom, the construction of scientific instruments of interest, the use of art as a starting point for reflection and as a demonstration of how art was an important medium in spreading new ideas, the use of new 3D technology with immersive virtual reality as a powerful way to involve the students. The ThingLink platform is the tool chosen for the teaching proposal. ThingLink is an innovative tool which allows to visually and interactively connect texts, images and videos and to build courses and lessons that can also be enjoyed in class and in a flipped classroom model. The peculiarity of this platform consists of being able to use 360-degree images that can be viewed on a laptop or in VR mode with a smartphone, by using a simple cardboard. Using a VR platform, the students benefit from rich opportunities in experiential learning, which are inclusive of all learning styles, needs and abilities. In the present case, a ThingLink project in VR mode has been created, bringing together multimedia content, significant places and works of art related to the theme and captured with a 360-degree camera. The educational path begins in Capo di Ferro Square in Rome, with a picture in 360-degree that can be watched in VR mode. We are now in the wonderful Palazzo Spada, and we walk through its rooms in search of a very important picture, Gli Astronomi, by Niccolo Tornioli, year 1642. The picture is a great historical testimony of the fundamental 17th-century debate between heliocentric and geocentric theory. The analysis of the painting introduces fundamental themes to reconstruct the millennial path that led to abandon the geocentric system. By opening the tag 1, we can explain the cosmologic vision of Aristotle. By opening the tag 2, we can explain how the Ptolemaic system was born, trying to resolve the problem of the retrograde movement of planets. We can speak about Copernicus, Kepler and others. ThingLink allows to involve the students with video, music and text. The following step focuses on Galileo's astronomical discoveries and their interpretations. We start in Venice, where Galileo lived 17 years. From the Tower of San Marco Square in 1609, Galileo showed his new telescope to Doge of Venice. Clicking on the tag of the telescope we get in the Galileo's room of Galileo's Museum in Florence. The student can explore the room and can observe the Galileo's telescope. Furthermore, following Seymour Papert, the father of the constructionism, who suggested that learning is more efficient when it is part of an activity such as making a handmade object, the students were engaged in a laboratory activity. The laboratory was focused in reading parts of Galileo's book, Sidereus Nuncius. Working in cooperative groups, the students built the Galilean telescope. With scissors, lenses, glue and paper, a 10x magnification telescope was built. Using the telescope, the students truly understood the observational difficulties of the past: small field of view, chromatic aberration, difficulty of pointing. Beyond the enormous observational difficulties, in 1609 Galileo pointed the telescope to the sky and with patience and precision, gave meaning to small details, turning these observations into great discoveries. Galileo observed the Moon, the planets and the stars, the Milky Way, Jupiter and many more sky objects. These observations wiped out 2,000 years of Aristotelian cosmology. At first, he observed the Moon and he interpreted the luminous points that he realized to be mountain tops. So, the Moon is made of the same matter as the Earth, and the division between sublunar and celestial world, typical of Aristotelian theory, does not exist. The art, at that time, wanted to represent this important discovery. We can get in the Church of Santa Maria Maggiore in Rome. We can look for the fresco in the Paolina Chapel, painted by Ludovico Cigoli. He painted the Moon as Galileo described it. Furthermore, Galileo discovered that the sky is populated by countless objects not visible to the naked eye. He observed the Milky Way and discovered that the white stripe was actually a collection of an incredible number of stars invisibles without telescope. And once again, the art wanted to represent this incredible discovery. We go then to the Alte Pinakothek in Munich and search for the painting The Flight into Egypt, from Adam Helsheimer, which is the first representation of the Milky Way as a set of stars. Finally, the discovery of Jupiter's satellites asserts the fundamental truth that not everything revolves around the Earth, and a celestial object can safely move in space without losing its satellites. One of the fundamental objections to the Earth movement was that the Moon could not have maintained its orbit in case the Earth was moving. This and other unresolved questions highlight the importance of rebuilding a new physics, no longer an Aristotelian physics based on a fixed position of the Earth. These and other discoveries brought Galileo to challenge authorities and prejudices. The new sky did not adjust to the universe of astrologers and that of Catholic religion. Galileo was put on trial and had to abjure his beliefs. Reading the abjuration, the students have discovered and recognized how much the genesis of science in the past had to struggle with prejudices, personal interests and abuses. The last part of the teaching path is in Florence, where we can visit the Galileo Museum. We can also visit the Galileo's house. The house, called Il Gioiello, is where Galileo, old and blind, lived and imprisoned the last years of his life. He died January 8, 1642. The same year saw the birth of Isaac Newton, as a natural continuation of a great mind's work. Switching to the final remarks, beyond the content presented, there are a lot of food for thought originated by the course itself, such as the contraposition between science and pseudoscience or religion, discussed with brainstorming and guided discussions methodology. The students have followed the course with interest and enthusiasm, and the final test has proved a good understanding of the concepts exposed during the project. Emotional side, the students' emotions were collected via an anonymous questionnaire. The outcome shows a range of feelings in the cluster of positive emotions. There is no sign of boredom, tension, sadness or anxiety, but only enthusiasm, happiness, fun, satisfaction and surprise. In summary, the history of science can be a good means to stimulate the interest of our students and may help to overcome the traditional separation between science and humanities. Again, the 3D technology is a powerful tool for students' involvement. Furthermore, previous findings can help to build an interdisciplinary STEAM curriculum and support the students to develop competencies and skills for the 21st century. As a final remark, the bottom line can be summarized as it follows. The work's outcome shows that students are ready to learn and participate with an active mindset. The key to the success is to find different or complementary approaches to traditional teaching methods.